Hello and welcome to the section on inverse functions. There's a couple of ways to look at inverse functions. So usually you would say take a function, and right now I'm not referring to this one, I'm just saying in general. You would say take a function, substitute some number, and you get an answer out. Well, with the inverse function, it goes the opposite way. So with the inverse, which is denoted f with a -1, you would plug in 17 and then you'd get out 3. Or another way to say it is the function, when you substitute 3 and then you do the inverse, then the function and its inverse will cancel and you'll just get the 3 again. Another way to look at it is if you look at a graph, so let's just make up some function, let's say it's like this. And you plug in 3, then it will take the x value of 3, plug it into the function, and then it will tell you the y value of 17. And then the inverse function goes the opposite direction. It takes the y value of 17, goes over to the function, and then finds out that x was equal to 3. So with that red mark right there, basically it's saying instead of starting with x, you're starting with y, and then you're getting x. So the roles are being reversed. All right, that was a brief overview, and now let's get to this particular problem. So basically with that little picture right there, the red part is saying that the roles are being reversed. So if I start with this particular function, and I don't need my graph anymore. So if I start with this particular function, instead of saying f of x equals, I say y equals. It means the same thing. Now reverse the role of the x and the y. So wherever there was a y, now use the letter x. Wherever there was an x, now use the letter y. And then solve for y. All right, in order to do that, I could add 4 to both sides. So these are going to cancel, and the left side has x plus 4. And then the next thing that I would like to do is get the 3y plus 5 on the top. So I'm going to multiply both sides by 3y plus 5 and 3y plus 5. So on the right side it simplifies very nicely and we just have a 2. On the left side I would not multiply this one out. So I would just rewrite it for now. The reason I'm not going to multiply it out is because this has the y information and this has the x information, and right now they're being separated, and so that's going to make it easier to solve for y. If for some reason this one had a y in it, then I would go ahead and multiply them out. But since it doesn't, the x's and the y's are already separated, so all I need to do is get a red pen and then divide, thank you, divide both sides by x plus 4. And after that, we only have 2 more steps in order to solve for y. So right now, I've got 3y plus 5 equals 2 over x plus 4. And then there's just 2 more steps. One is subtract 5 from both sides. Those are going to cancel. And what's left is 3y equals the fraction 2 divided by x plus 4, and then minus a 5. And on the right side, you don't have to get a common denominator. You can just leave them like that. The last thing to do is divide both sides by 3. So if you divide by 3 on the left, you need to divide by 3 on the right. And because this has two terms, both of them need to be divided by 3. And then we've solved for y. So the last step is replace the letter y with the inverse. And then we have our answer. And that is the inverse. Oh wait, there seems to be something that I forgot to do, and that is I forgot the part about verify that it's 1-to-1. So that basically just means that I need to graph it and see if it passes the vertical line test. So for example, a circle is not 1-to-1 because if you can draw a vertical line and intersect it twice, that's not 1-to-1. So I just need to graph it. And for that, I think I'm going to go and use Desmos just for something different. So I've got y equals, then it was 2 divided by, and one thing nice about Desmos is I don't have to use parentheses because then it says the denominator is 3x plus 5, and then move to the right to get out of the fraction, and then go minus 4. And then if you look at that graph, it looks like there's no place where a vertical line would hit twice. I could also go like this. So for a vertical line, that means x equals a number. So for example, x equals 1, you could see that it only hits the graph right there. And if oh nice, I can even move this around, and then you can see that it's only hitting the graph at one point. So that's the point. Oh, it's not showing up, but it's only hitting the graph at one point. So it seems that yes, this is 1-to-1.